question. It's a past question from the May-June of 2015, paper 2, question 12. So it says, given that M is equals to the matrix 1, 2, 4, 3, and N is equal to the matrix Mx, Ny, and Mn is equals to 2, 1, 3, 4, find the matrix N. Okay, so given this matrix M and this matrix N that has some letters in place of numbers, and the product Mn is the product of M and N, that's M times N gives you this product. So we have to find the matrix N so that so basically we want to fill up the letter. Right, so let's get to it. So M times N, so we need to do some matrix multiplication. You know that for two matrices to be multiplyable, okay, the number of columns in the first matrix must equal to the number of rows in the second matrix. So the number of columns here, we have column 1, column 2, and it's equal to the number of rows in matrix M. First row, second row. So we have 2 rows here in second matrix, and it's equal to the number of columns in the first matrix M. So 2 columns, no columns are vertically. So 1, column 2 is equals to row 1, row 2. So we have, so this matrix can be okay. So the two matrices conform to multiplication. They can be multiplied together. All right, so let's get to it. So this is Mn solution. Mn is going to look like this. Create a bigger rectangle. So row by column. So the first row multiplies the first column, right? So 1 times M plus 2 times N, right? Like that. So first row multiply the first column. Now the first row is also going to multiply the second column. So I go 1 times X plus 2 times Y. All right. So that's the first. So we created the first row. Now the turn of the second, using this second row for the first matrix against all the elements in the second matrix. So the turn of the second row. So 4 and 3 will multiply M and N, and then 4 and 3 multiply X and Y. So let's go. So we have 4 for the second row, 4 times M plus 3 times N. So you see the way, row by column. So second row again, now multiply the second column. We'll lose space. So put a little space. So we have 4 times M plus, 4 times X. Yeah. Right, so we continue. Like I said, so the second row is going to go against the first column, second row, second column. So 4 times M plus 3 times N space 4 times X plus 3 times Y. So we've done the first, column there. So 4 times M plus 3 times N. Then 4 times X, okay, 4 times X, plus 3 times Y, 3 times Y. So that gives us our second row. So we've gotten everything. So everything is down, so you can simplify. All right, so we can simplify. We are through with our multiplication. Okay, so simplify. So let's simplify. 1 times M is M plus 2 times N. So M plus 2N in our first. So this is our first row, first column. So we have then over here 1 times X, leave the space there, plus 2Y, 2 times that. Then this is 4M. Yeah, this is 4M plus 3N. 4M plus 3N. And over here in the second row and the second column, we have 4 times X, which is 4X plus 3Y. You have to agree. Good. Right? All right. So let's go back to the question again. It said, given that M is this, the matrix M is this, the matrix N is this, and Mn, the product is this, find the matrix N. All right. So our product have been given values, okay, or numerical values. So, and we've done the normal multiplication. So you equate it to this. So all of this expression, algebraic expression, should be equal to. So the element on the first row, first column is 2. The element in the first row, second column is 1. The element in the second row, first column is 3. And the element in the second row and second column is 4. So basically, I'm going to equate n plus n, 2n equals to 2, x plus 2y equals to 1. Okay, so we are told from the question that the product mn has these numerical values. So if you equate the multiplication we just did, which is all of this, and which is simplified as this, equate it to this. Okay, so equate each element in your product. Look at each element in our product, our multiplication, to the values given from the question. So I'm going to go and say n plus 2n is equal to 2, x plus 2y is equals to 1, 4n plus 3n is equals to 3, and 4x plus 3y is equals to 4. Okay? Okay. So we are told from the question that the product mn has these numerical values. So if you equate the multiplication we just did, which is all of this, and which is simplified as this, equate it to this. Okay, so equate each element in your product. Look at each element in our product, our multiplication, to the values given from the question. So I'm going to go and say n plus 2n is equal to 2, x plus 2y is equals to 1, 4n plus 3n is equals to 3, and 4x plus 3y is equals to 4. Okay? Right, so let's see what this gives us. So we have that to give us a simultaneous equation, I guess. So n plus 2n is equals to 2. We have, then we have 4m plus 3n, because I like to bring the letters together. 4m plus 3n is equals to 3. All right. So this gives us a simultaneous equation in m and n. Then for the other one, we have x plus 2y equals to 1. You have to agree. So 4x plus 3y equals to 4. Okay, so we can solve simultaneously. Over here, we could say multiply equation 1 all through by. Okay, so we have been able to arrange this like this. Okay, so what I did was to multiply equation 1. This is n plus 2 and all through by 4. So multiply equation 1 by 4. So this becomes 4m, this becomes 8n, this becomes 8. So that it looks similar to equation 2. And then you can easily subtract equation 1 from equation 2. So subtract 4m minus 4m disappears. 8m minus 3n, you're left with 5n is equals to 8 minus 3 and get 5. All right. So divide both sides by 5, you get that n is 1. Do something similar here. Multiply all of this by 4. So say 4x, that's equation 1 by 4. 4x plus 8y is equals to 4. All right. All right. So I've done something similar with this pair of simultaneous equations, right? All right. So multiply all equation 1 by 4. So it becomes 4x plus 8y. This 4 times 2, 8y. 1 times 4, 4. Why are we doing that? So that it looks similar, so that you are trying to eliminate x. So let them have the same coefficient. So by the time you do this, minus, so 4x minus 4x gone. 8y minus 3y, I have 5y. 4 minus 4 is equal to 0. So y becomes 0 over 5, which is 0. Divide both sides by 5. So y equals to 0. So we have an equation value for n. So n equals to 1. You can easily substitute into any of these to get m. And y equals to 0. Substitute. All right, just to go over this little detail here, we have x plus 2 into y. We've gotten that y equals to 0. So anywhere you see y, substitute 0 in there. So x plus 2 times 0 is 0. So it's x plus 0. So if 0 comes over, it becomes 1 minus 0. So we'll have x equals to 1. So we have m equals to 0, x equals to 1. Okay, so our matrix now, so our matrix, okay, this is our matrix mxny. So mxny, so mxny, n equals to mxny. So m is equals to, okay, let's check that out. M is 0, 1. All right, so we've gotten m as 0, x as 1, y as 0, n as 1. So the matrix, so find the matrix n. So matrix n, mxny. So just put in the values there, and we have mxny is 0, 1, 1, 0. So we've gotten the answer.